Hello student. Yesterday we have to see the preparations methods that are to be used for the preparations of supposed to be our alkyl halides. Continue to this. We have to see the next methods that is used for the preparations of the supposed to be our alkyl halides. In the previous lectures, we have already see that the preparations of the supposed to be this our alkyl halides from the alcohol with this continuous. We have to see the next preparations methods, that is the preparations of the alkyl halides with the help of the supposed to be our hydrocarbon. So now see here. So in this case, in this case, we are going to prepare this alkyl halides from the supposed to be our hydrocarbon. We know that the organic compounds which is containing the carbon and hydrogen is called as the hydrocarbon. Definitely, hydrocarbon may be the supposed to be our saturated one or supposed to be our unsaturated one. It means that the preparations of the alkyl halides are formed from the supposed to be our saturated hydrocarbon and unsaturated hydrocarbon. If you consider the saturated hydrocarbon, it means the supposed to be our alkane, and unsaturated hydrocarbon, it means supposed to be our this alkene. Definitely, in this case, if we have to see the saturated hydrocarbon, so the halogenations of the supposed to be our alkane, because alkane is the saturated hydrocarbon. It means that halogenations of the alkanes is not the suitable methods which is used for the preparations of the supposed to be our alkyl halides. Whenever we used the alkane for the preparations of the alkyl halides, then definitely there is a formations of the mixture of mono, then di, tri, tetra and polyhalogen derivatives or polyhalogen compounds. The separations of these mono, di, tri and tetra is difficult. That's why the halogenations of alkenes is the crude method. The halogenations of alkenes is not the supposed to be our suitable methods. So then we consider here in this way, we consider here supposed to be the preparations of the supposed to be our preparations of the supposed to be our alkyl halides with the alkenes. So these alkyl halides can be prepared with the help of the alkenes. Definitely. So alkenes may be the symmetrical one alkenes, and alkenes may be the supposed to be our this unsymmetrical one. Additions of hydrogen halides, correct here. This is the supposed to be our alkene one. Definitely alkyl halides are formed with the additions of the hydrogen halides to the supposed to be our these alkenes, which means the carbon-carbon double bonds. We have to do the additions of the supposed to be our hydrogen halides. The general representations of the hydrogen halides is the HX. X stand for the chlorine, bromine, and supposed to be our iodine. It means we are adding the hydrogen chlorides, we are adding the hydrogen bromides, and we are adding the supposed to be our hydrogen iodide to the corresponding alkenes. Definitely results in the formations of the supposed to be our alkene halides. Definitely these alkenes are of two types. It means that symmetrical alkenes and unsymmetrical alkenes. the additions of the hydrogen halides to the symmetrical one alkenes and unsymmetrical one alkenes is giving the supposed to be our different types of the product. Whenever we added the supposed to be our hydrogen halides, generally we are using the hydrobromic acid, it means HBr, because HCl and HCl, HBr and HI, in between HBr is there. So the bond dissociation enthalpy of HBr is moderately. That's why we are going to take for these additions definitely HBr. So when the HBr get added to the supposed to be our symmetrical one alkene, when alkene is symmetrical one and the additions of HBr to the symmetrical alkene is giving the supposed to be the only one products. It means so there is no difficulties arises when the addition is supposed to be our takes place. In this case, so so continue this, the additions of HBr to the symmetrical alkenes is yields only one products. So example, consider the ethene, that is CH2 double bond supposed to be our CH2. This is ethene. Ethene is reacted, so it supposed to be our HBr. Definitely, when such type of additions takes place, there is no problems for the additions of these reagents to the carbon-carbon double bonds. Definitely, there is a formations of CH3, CH2, and supposed to be the Br. This is called as supposed to be our ethyl bromide. Ethyl bromide, or simply it is considered as a bromoethane. Bromoethane. In this way, because these additions, because considerable alkene is the symmetrical one. If you cut these molecules across the carbon-carbon double bond, we are getting the two symmetrical parts. So whenever these unsymmetrical reagents get added to this carbon-carbon double bond, there is no problem for these additions. So hydrogen get added here and bromine get added here. That's why there is a formations of the supposed to be our only one products. So these examples we can represent also in this way also. In this way, supposed to be the CH2 double bonds CH2, then additions of HBr, definitely there is a formations of such type of the Br, then CH2 and supposed to be our CH2. In this way, we can simply consider that whenever the additions of the HBr to the symmetrical one alkenes, there is no problem of the additions of the HBr, because there is a formations of only one supposed to be our product. But the problem arises when the additions of HBr to the unsymmetrical one alkenes. These additions takes place with the help of the special type of the rules. That rules is called as a Markovnikov rule. So whenever this HBr is added to the unsymmetrical alkenes, there is a formations of the two isomeric products. How they isomeric products they are being formed, just we will see here with the help of supposed to be our examples. That is the propene CH3CH double bond CH2. When this propene is reacted to the HBr, in this way, this propene is considered as a unsymmetrical alkene, we consider here one propene or simply supposed to be our propene. This propene is the simply unsymmetrical one. Why? If you cut this molecule across the carbon-carbon double bonds, we are not getting the supposed to be our symmetrical parts. That's why this is the examples of the unsymmetrical alkenes. And unsymmetrical alkene reacted with the simply these unsymmetrical reagents. Definitely, we are getting the two products. Product number one, there is the chances. So in first cases, this hydrogen get added here and this bromine get added here. In this way, supposed to be our CH3, then CH2, the CH2, so Br. This is considered as a one bromo, supposed to be our propane. This is the product number one. And in another cases, this Br get added here and hydrogen get added here. We will get, that is the CH3 added to the when unsymmetrical reagents is added to the unsymmetrical one alkene, the negative part of the reagent get attached to the alkene which carry the less number of the supposed to be our hydrogen atom. So consider here example. This is nothing but this is the unsymmetrical alkenes. Why it is called as the unsymmetrical one? So because if you cut these molecules, we are not getting the two symmetrical parts. Secondly, we are considering here reagent, that is the HBr. This is also the unsymmetrical one because this is the positive parts and this is the negative parts. So these unsymmetrical reagents, when an unsymmetrical reagent is added to the unsymmetrical one alkene, the negative part of the reagent get attached to that carbon atom which carry the supposed to be our less number of hydrogen atom. That's why we are getting the 2-bromopropane as a major product. तर जो काही major product आपल्याला obtained होतो, so that major product is the supposed to be our 2-bromopropane. It is the supposed to be our Br. So in this way, we are going to prepare the supposed to be our alkyl halides. So in a symmetrical way or in a unsymmetrical way also. When given alkene is unsymmetrical one, there is no problem. But when the given alkene is unsymmetrical one, that time we have to do this addition with the help of supposed to be our Markovnikov rule. Exactly reverse to that. That is the simply consider as a supposed to be our this anti-Markovnikov rule. With this, what is mean by the supposed to be our anti-Markovnikov rule? Definitely, the product which is obtained with the help of Markovnikov rule. So opposite to that, that is the anti-Markovnikov rule. But condition is that if in case of anti-Markovnikov rule, these reactions is carried out with the help of supposed to be the organic peroxides. These reactions is carried out with the help of organic peroxides such as benzol peroxides or supposed to be our hydrogen peroxides. We can explain this anti-Markovnikov rule reverse to or opposite to the Markovnikov rule. It means that there is a necessary of the unsymmetrical alkenes. There is a necessary of the supposed to be our this unsymmetrical reagent. We define anti-Markovnikov rule in this way also. So when an unsymmetrical reagent is added to the unsymmetrical one alkenes, the negative parts of the reagents that attached to the carbon atom which carry the supposed to be our more number of hydrogen atoms. For example, consider the propenes, that is the CH3 CH2 CH3 CH double bond supposed to be our CH2. In this way, here is the CH, then double bond, then CH2. This is our propene. When propene is reacted with simply our HBr in the presence of peroxides, peroxides, the addition is takes place reverse to the Markovnikov rule, and the major product will be obtained. That is supposed to be our 1-bromopropane. In this way, CH3, then CH2, and Br. This is the major product, and this product is obtained exactly with the or exactly reverse to that of the supposed to be our Markovnikov rule. Again, anti-Markovnikov rule says that, or this rule is only shown by the HBr, and the additions is in these additions the negative part of the reagents is get added to carbon atom which carry the supposed to be our more number of hydrogen atoms. म्हणजे आहे त्याला पण जाऊ द्या इथं थांबून घेऊ हायड्रोजन एक्सचेंज हे थोडंसं पहिले